Good morning, students. Welcome to the online lab sessions. So this is our second class. If we consider the lab classes, so once again, this is I welcome you to the labs, these lab classes. So now, if you remember, this is this is a second class. So if you remember that what we have done in the first class, that we in the first class we dealt with, rather we have witnessed that what is the effect of heat on lead nitrate salt. We over there, if you remember, if you watched the video over there, then you must have noted, you must have witnessed that how lead nitrate, a white crystalline salt, get decomposed by the effect by, or rather due to heat. So the formation of reddish brown gas, that was nitrogen dioxide, that formation of yellow residue, that's and I mentioned over there it was letharge, and along with that oxygen is also getting evolved, which is not visible. So now, along with that, the observations. So what are the observations we are having? So all these things we have already discussed in the previous class, and I hope you've enjoyed the classes under right now. So today, this time, or rather today, we will be moving as promised, that we will be carrying on with more such experiments like that. So today we are going to carry out another set of experiments where you will be able to see certain, once again, beautiful observe or rather color changes, precipitate formation, residues, and all the stuff. So the today's session, it's not the effect of heat, rather. So we were going to check out the effect or other reactions between two different chemicals, where one of the chemical will or rather is as lead nitrate was taken the previous time. This time also here. So lead nitrate, but in a solution form. And along with that, we will check out the interaction, the reactions, how they react to different chemicals. One is hydrochloric acid, and another one is potassium iodide. We are going to check it out, how they react with each other. Okay, not we, so each other. So without wasting any more time, so let's move on to the video straight away.
We are going to perform another experiment. What I'm going to do is, we will take this another transparent solution, which you can see. It's a clear transparent solution. Nothing is there. No color, nothing. Transparent solution and colorless solution, both. This is lead nitrate solution. Once again, I've taken lead nitrate solution. What I'm going to do is, I'm going to add two different chemicals inside this lead nitrate. I've taken basically same lead nitrate solution in two different test tubes. And in two different test tubes, I'm going to add two different chemicals. What I'm going to add, the first one I'm going to add is, this is Ki, potassium iodide. This solution I'm going to add in the first test tube. Okay. This I'm going to add in the first test tube. Let's see what happens. If I add potassium iodide inside lead nitrate, just check it out. It's mustard yellow precipitate. It's a mustard yellow precipitate has formed. The entire solution has changed into a mustard yellow, as you can see, isn't it? It's a mustard yellow. It's a clear solution. The entire solution has transformed. You can see there's a clear transformation has taken place from transparent colorless solution to a mustard yellow colored solution. And the colored solution, not colored basically, the precipitate. If I keep it this solution for some time, you can see the residue or the precipitate will start sedimenting. At the base, you can see the top portion is a colorless solution, it's forming. At the base, once again, a yellow precipitate is forming. With another test tube, where I took this lead nitrate solution. Now I'm going to add another solution. What I'm going to do is, I'm going to add this. You're very much familiar with this solution, very familiar, dilute hydrochloric acid, or normal hydrochloric acid only. You're very much well familiar with it. Let's see what happens if we add dilute hydrochloric acid or hydrochloric acid. It can be concentrated also. If we add this one to lead nitrate solution. From a transparent solution to a white insoluble substance. You can see that one. from a transparent solution to a white insoluble substance. You can check it out, isn't it? It's a white insoluble substance. I hope you can see that one very clearly. It was previously transparent. No, nothing was there, colorless. Still the solution is colorless, but a white substance has formed. White precipitate has formed. That is of, this is basically due to lead chloride. Alright? Now, this one thing you shouldn't do, which I should mention over here, I have handled the acid bottles with my bare hands. But you are not going to do this one with bare hands. Okay? We are carrying out experiments, we know the precautions, we know what to do and when to do, how to handle bottles. For that reason, though I have done that one, scientifically it's not correct, but you shouldn't carry out these sort of experiments with bare hands. You will use droppers and you will use test tube holders when you are performing experiments with acids. Alright, so I'm going to just show you in short the reaction of this particular experiment. I'm just going to show the reaction of this particular experiment. This is basically the first one I showed you. This is lead nitrate. With lead nitrate I added Ki, and this forms lead iodide. This is actually the yellow PPT. Okay, this was actually the yellow PPT, and this forms potassium nitrate. Please do balance the reactions, alright? I'm writing over. Again, I took that lead nitrate and I use HCl, and I'll give over here it's PgCl2 plus HNO3. I hope the reaction is balanced. And this is actually, once again, this is the precipitation sign, and this is the white. So that's all for today's demonstration regarding experiments. So we'll carry on with much more experiments in our next class. Thank you so much.
So there you've seen the experiments being carried out, and I hope you have enjoyed these reactions, the experiment, the precipitate formation, the color changes which have taken place, and definitely along with that, you have definitely recorded and noticed the different observations. So, although it's mentioned over there, though I mentioned, it's already mentioned over there regarding the reactions, but there was while writing part, there was a small error has been there regarding the balancing of the first reaction. So, I'll move on to the final conclusions from this particular experiments. So there it goes. The reactions. There was a slight mistake in the previous demonstration reaction. There was a small error. So the actual reaction is all the error regarding the balancing part. So lead nitrate PbNO3 plus 2 Ki. The 2 was missing, whether nothing else. The rest it's 2 KNO3 PbI2. It's absolutely fine. It's mustard yellow precipitate, and the rest are solutions. So the only 2 was missing. The actual balanced reaction is this. Followed by, if I consider the lead nitrate, it's 2HCl and PbCl2 plus, and with lead chloride giving a white precipitate. That's all. So moving on to if we focus on the observations, the observation of the first reaction is mustard yellow precipitate forms within the transparent colorless solution. So it was previously a transparent colorless solution. If you consider the lead nitrate solution, it was a transparent colorless solution. And if you focus on the second, that's for based on that, it's a mustard yellow precipitate forms. Mustard yellow. This is the most important keyword, rather, mustard yellow precipitate forms. The second is with case 2, we are having a white precipitate forms within a transparent colorless solution. The transparent colorless solution is a common one. So, in other words, white precipitate forms within a transparent solution. Okay, so white precipitate. So, 2 distinct observations. So that's all with regarding the observations and regarding the today's practical class, other lab sessions. So we'll definitely going to catch you up with some more experiments in the upcoming classes. So till then, take a very good care of yourself. Stay safe. Thank you so much.